Oh, it's another day of not very warm and not much solar. Let's have a look at the power. 2.62 amp solar input, marvellous, 50.8 volts. Let's go have a look at this, the changeover switch, and it's gone. What's happened? It's actually, it's just a shadow, that's not a shit stain on the wall. It broke. I came home one night, I had no mains power. And it's this boy's fault. So I've started taking it apart and I thought, actually, might as well, I don't know if anyone else has had any of these blow up yet, so I may as well have a look. Let's tear it in a bit. Right. So these come apart pretty straightforwardly. You flip them over on the back and there's all these little holes where these tabs stick through. You push them off. You've also got to take all the wires out first. Do that both sides. You need to get this dial off. Underneath the sticker is a screw, so unscrew it. This then kind of lifts off and that flops forward. And then that's the insides of it. So you can see exactly how it works. Or how it's supposed to work. So, motor, big motor drives a big turny thing. Big turny thing, switches one off and then one on. So you'll see this one snap off, snap, and then this one is pushed on, click on. And the same the other way, so it's a interlock. So that one gets clicked off and then that one is pushed on. Simple, isn't it? Got limit switches so it knows when it's at the right place. It's a very simple circuit, or simple enough circuit. As this motor turns these back and forward, you can see it actuating the little limit switch there. You can hear it clicking. Same the other way, out and put your fingers. Does click, that does work. That's not the problem. The problem is, I run this with it in backup power, it's the mains, and common power supply is the inverter. So whenever the inverter switches off, it goes to backup power, which is the mains. Should be able to do that, no big problems. But what happened with this one is, I came home to find it on inverter power, and half the things in my house, the hydro things like the cooker, the shower, mainly the shower, because I wanted a shower once I got home from work, because I was filthy, and it didn't work. And then I look over at this, and the red light's not on. Oh, that's no good. I should have the red light on both sides to see if the inverter's on and the mains is on. So I need the mains to have a shower, but we were using the inverter for power at the time. So, I'll bring you down a bit. Right, stories aside, here is the that giant motor to make that big turning thing work. And then I looked in here. Cast a bit of light on it. Can you see anything wrong looking in there? Anything looking a bit black and exploded? Yes. Something's vaporised in the top corner of that box on the main side. It does look very burnt. So we need to get that board out and have a look and see what on earth has gone wrong. Then I explain why every time I turn it on, it blows the trips out in the I think they're like 100 amp breakers. It blows them. So yeah, what's going on here? They're built to a price, these things, they really are, aren't they? Anyway, let's have that board out and see if we can work out what's happened. Right, so I've done all 3 screws that they decided to put in. Probably need to get the little on-off switch wire off. This should come out. Oh my word. Oh dear. Oh. Well, it's vaporised something. We're going to have to clean this up so we can see what's gone wrong, but that is not looking good, is it? Yeah. That might be why it doesn't work anymore. I've got a feeling that that's probably the issue. Right. I'll clean the board up and see if we can make any sense of what on earth has happened. I'm going to lean towards saying maybe one of the relay contacts is stuck. Oh yeah, looks like there's a shit stain on the relay. Now, one of the contacts may have stuck connecting live with the inverter to live with the mains, or vice versa. Joys. Right, let's pull all these wires off. Taking a picture using my phone so I don't remember where it all goes if I ever get it working again. Right, so I've harvested the board out of it now. Take a bit of time to actually look at it. See all the relay contacts of these groups here. I've got a blown track there, something seriously blown there. And I was looking at the side of the relay. You can see the little if I put my skin behind, you can see the little burn flash inside the relay. So something got stuck in there for some reason and decided to send current through where it wasn't supposed to go through. So, let's see if I can pop open relay. Here's this design. I've seen other designs of this by the one that Big Clive had, and this was on like a silly little sideways board, and he said it was a nightmare to work on it. Whereas they've actually just through-holed this. That's just crap a design, it could well be, but there we are. I've got the lid off the relay. Whatever the problem was, it seemed to rectify itself, but I imagine those contacts for some reason managed to stick. Don't look terrible, but yeah, there's definitely a poo stain inside of there where it all went a bit wrong. Yeah, I'm going to clean off the soot and we'll see what's going on under here. Right, so I've cleaned her up, and what we can see here, if I get it zoomed in, we are over here. Yeah, I get too close. So what we've got is this part of the track here that is completely vaporized around that post. That track, if you can see, goes up here to here. And there's still a bit of it left. There's a bit of the remaining track. Try and get the light right. You can see this next track here. It goes around up here, in between those two across, and to that pin is completely blown. That's gone. The rest of the tracks seem alright. So obviously we're going to have to resolder this. We've actually got something bridging, it's probably melted solder bridging the two there. And that's gone. I've eliminated that. So the question is, if I just reconnect this back to there, so basically just a jump wire from there to there, sorry I'm looking at the camera, there to there, and from there to there, make sure that connection also works. What's the chances of it actually working again and not just blowing into flames? I mean, I'm going to leave, I'm not going to do it in too thick a wire because that's obviously was a good fusible link for blowing up when everything went wrong. That bit there's also bridged with a piece of solder. Not anymore. Yeah. Apart from that, looking around the rest of the board, use the light to our advantage. There's nothing else to sort out. So those two pins were power input. Those, so that was where the power was coming in for main side in. And the only other thing we've got to think about is this guy any good? Any of these stuck? These all seem to be working, and it's not stuck in any position. So why did it happen? What caused the failure? I'm not sure. I mean, the relay's got a shit stain on it because, are you surprised? It looks like it had a fair bit of current jammed through it. But why did it happen? Any ideas? So what I do is I'm going to wire that to that, and that back to that, and we're going to run it on the bench. We're not going to put it back into actual service. We're going to see how it actually works and see if it explodes. Do that now. So imagine this feels like a bit of a step back in time for some of you who've been around for a while. we're back in the van. Just because I've got a vice in here and all my electrical stuff's in here. I want to try and get rid of that piece of track there that we don't want. I'm going to remake that and get that, expose the solder mask on that pad so we can reconnect him. Probably do. I believe this is only for driving the LED anyway, so scratch off the solder resist, or solder mask, whatever the hell they call it. And that should get us back on there and get to that, and we can get to that. Let's run some fresh solder on. Try and make this a bit easier. So I've got this contact here. Good. Tin that there, so that's bridged back up. Sort of. Doesn't want to, but it's going to. It's got a connection, that's all it needs. It's not a good one. And that one's back on. Some close on here. And some on here. Good. Right. Now I need some wire. So I'm going for some real thin wire because I don't want any real current carrying capability for this circuit. So knowing that it has been having itself previously. Oh, get that in there. Tin the end. Good. And trim it down quite a bit. So that's going to go to this one. And let that go. And that needs to go to that one there. So I'm going to make life easy. I'll try to make life easy. And use a slightly longer bit of wire just to make it so I don't have to work too hard, you know what I mean? Nobody wants to do extra work. That, and I want to be able to strip this wire as well. Could have cut it to length and did it first, but what we're doing, this will work. Right. What else is life surrounded by things that constantly break, or is it just me? So that track used to go to that pin there, and that is where it shall go once again. There it is. First one. Second one's got to go from there to there, and that is all the broken tracks replaced. Can't see how well you can actually see what I'm doing, but I'm sure it'll be fine when it's on the big screen. Somebody's probably shouting at me, "You can't do that." It's not good enough. And would you really want to put this back in your home afterwards? My answer is, until something else arrives, yes. I need it to work. I'll tin that one up. Trim it down. And that's going to go from this post here. Contact the relay. Which way up my soldering on that way. Lower on, lower set. Bring her over here. She's going to do a bit of a loop just so I don't have to deal with two short wires. It's a weekend. I don't want to be doing stuff that's fiddly and awkward. That's weekday stuff, that is. And a bit of tin on that one. Never stress enough, good solder. 60-40 tin lead. Lots of flux in it. That's what you want in life, otherwise things are difficult for no reason. And that's on there. So that should be repaired. Unless we're about to find out what the other underlying issue is. So yeah. Let's go wire it back up and let's have some fun. Oh, and just in case anyone's wondering, this has got to be clean. The reason being, it may just look like soot and death and horribleness. It's actually potentially conductive vaporised copper in there. I'll try and get that switch out. It might not want to come out, or she's going to come out, or I'm going to stab myself in the hand, one of the two. It's trying to come out, there we go. You remember which way that went? It doesn't matter. I'm just going to use brake cleaner, brake parts cleaner and sacrificial toothbrush, because we've got to get some of that out of there. You can actually see, if you look at it, catch it at the right light, you can see, well, that looks like plated copper in there. And looking at it, it's probably not going to come out either. Oh well. If it works, it works. If it doesn't, never mind. Well, these like 30, 40 quid for the whole thing. I hate throwing stuff away like that, but you know, oh well. Let's put it back together. I've got to put the switch back in. Oh well, I'll be fine. I think it went that way. That looks about right to me. Plugged in there. Put the screws back in, and had 3 to start with, so we put exactly 3 screws back in. Even though there are 4 screw holes, just 3 of them are actually in. Oh, steady. Check that one in, come on. It's almost Christmas as well, just in case everyone knows. I've got the Christmas decorations are out. One singular tree. I didn't put that back on. I'll fix that. Let's grab the guts of it. There she is. You remember how it plugged in? No. Luckily I took a picture. You know you probably do. There it is. Shows us how to do it. Always worth taking pictures. So, with the block, this is an electro boom. It's not going to explode because it's not powered on. Get more views that way, but it's not going to do it. Oh, lovely. Judging by the way those two line up, they're probably left and right. Make sure you take note of that. 2 of the connectors are the same colour wires and the same size. Nothing works and it all explodes. That would make sense. Right. What I need to do now is provide it some electricity. So if we hold on a minute, I shall attempt that. Right. Never copy what I'm doing here. Today I have Jimmy's electrical probes of doom. Anyway, hopefully it doesn't explode. Nothing's connected yet. These are my power input wires, which are now got to go 5 one side. See it doing that? We got it wrong. Turn these off. They are off, right? Off. Good. Safe. So when I said I could got those 2 limit switch wires the wrong way around, did you see it was going the motor was stalling where it was trying to turn? So I got those wrong, which is fine. That one has to come out. That one has to come out. Why these aren't on a 4-pin connector is beyond me, but never mind. I did not design it. I did nothing. Right, get my electrical pokey things of doom again out. Ready? Let's turn that on. What happens now? Still having issues. Turn these off. They're safe again. They are switched off. I'll show you what I'm doing wrong. I'm going to plug those wires back in where they were, because as I reckon they were in the right place in the first place. Out they come. Plug them back in. If we look down here, I'll bring you down a bit. Ooh, where you can see what I cocked up. Can you see it yet? So if we bring this back in, have you noticed this bit was sat above the switch? There, rather than under it. If I bring it back a bit, there we are. So when that comes around now, it'll hit the stop. Silly James. Right, let's just wire up again, see what happens. Where's me electrical probes of ultimate doom? This is extremely dangerous way of doing this, but it is also the quickest way of doing this. Power's on. Feed power to those two again. That side is now on. You see the lights on. Now if I connect it to the other side, is it going to explode? 3, 2, 1, please don't blow up. And there you go, it's done its thing. I'm not exactly sure what happened, but you can see if I connect this side up where you can actually see it this time. So, ready, the backup power is about to come on. What happened there? What I might do, I might turn this around a bit better so you can see it. I can see the contacts a little bit better. Normal power. Backup power. Yeah. Normal power. Why does it buzz? It's because the relay's always on when it's on common. Backup. And back to normal. It's interesting to note that when it's in that mode, in normal power, that relay is always on. So power's off. Make this safe, don't want these left lying around anywhere for anyone. And there we go, it appears to be working. What caused the fault is anyone's guess. It's annoying because I don't know why it was broken. Just carefully check them, look round, carefully put it back together, channel the wires back somewhere out the way, like that. Wires out the way, no. I've got to go around the relay through the gap. That's how those are powered. Make sure the other ones are right, everything looks right there. Not too much loose stuff in it. Cover. So get back on over everything, like so. That's that cover on. The single screw that holds the entire thing together back in. Let's take two, but there. Inverter, this side, kind of goes in. What am I doing wrong? Oh, sorry. Grid has this bit on the side, it goes there. In there, bottom first, over the top, and then back through, and see the tabs come back through. So we go into the inverter power side, so the back in first, in. There we are. This is keyed, so it can only go that way or that way. You can have it like that, or you could have it like that. It'd be really odd and confusing, but now we're going to have it like that. Goes on there. Screw goes in, draws it on. Back to work she goes. Do you trust it? I don't. But I'm going to put it back to work anyway, so that's what we're going to see next. Oh baby. 3, 2, 1. Please don't blow up. Onto grid. Switch the other one on. Junk. It's alive! Now just go turn the solar on and see what happens. Full power supply. Good that, it's good that. No fires yet. Try again. On. Marvellous. Radio. Let's go turn the inverter back on. Yay! It worked! Wow, it works! I've ordered a replacement. That's probably not going to stay there, but another one fixed. Woo! Next time.